Hi, my name is Cindy Garza and I'll be explaining synaptic communication. To commence this process, we need to know about the neuron. And so basically the two main parts about the neuron that we'll be focusing on in order for synaptic communication to commence would be the dendrites and the axon terminal. So basically the dendrites are what brings the messages into the soma, or in other words, the body of the cell. It will pass the axon helix, and once it reaches the axon terminal, we are ready for action potential to commence. So right here in action potential, we have various stages. The first being the resting potential, in which the negative charge is intracellularly and the positive extracellularly. So then we have the threshold at negative 55 millivolts. Oh, and another thing I forgot to mention, resting potential happens at negative 70 millivolts. Moving on, the threshold being at negative 55 millivolts must be reached for the action potential to be fulfilled. So if we keep traveling up, you reach depolarization. A little bit more, you will reach the peak of the action potential. Going down into repolarization is when the closes the sodium channels and opens potassium channels. Going down to the hyperpolarization is when it's putting the axon to the refractory period. With that being said, synaptic communication will commence. So right here we have the axon terminal of a presynaptic neuron, which sends the messages, and you have your negative charge on the inside and your positive on the outside. Inside the terminal you will find vesicles. Inside the vesicles there will be neurotransmitters, which are two classes of neurotransmitters. The first being excitatory, which both sodium and calcium go into the cell, causing depolarization, thus promoting action potential. The second being inhibitory, which chloride flows into the cell and potassium flows out, causing hyperpolarization, which then suppresses action potential. With that being said, you have receptors on the postsynaptic neuron, which is this, and it is what receives the messages. So, in other words, you have the ligand-gated ion channels or the ionotropic receptors. So, moreover, action potential will then commence. Thus, you have your signs, your charges changing right here. So now you have positive on the inside and negative on the outside. This effect will cause the calcium-gated channels to open, which is right here, and calcium will diffuse into the terminal, allowing the vesicle with the neurotransmitters to diffuse into the synaptic cleft. And this process right here, in other words, the time in which the neurotransmitter goes through the synaptic cleft is known as the synaptic delay. So to conclude synaptic communication, the last process is basically the neurotransmitters binding to the receptors.